Okay, in this question, we're told that there's a craft activity in a primary school where the children are using different coloured beads in a bag, and there's a large number of these beads. The beads are not replaced in the bag at the end of the activity. It's known that 3/10 of the beads are gold coloured. The teacher claims that the children are going to use more gold beads during the activity and checks a random sample of 20 beads at the end of the activity to try and justify whether or not she's correct. We've been asked to do a hypothesis test at the 5% level of significance level on whether or not there's evidence to support the teacher's claim. Okay, so let's just start with some of the standard things. In this hypothesis test, X is going to follow a binomial distribution where n equals 20 and p equals 0.3. That gives us an expectation of 6. The null hypothesis will say that after the activity, 3/10 of the beads are coloured gold. This would mean that the children used up an even proportion of each of the different colours, or an even proportion of gold and the other colours. So that's why the proportion remained 3/10. If they used more gold, then the proportion of golds in the jar is going to reduce. So this is where the null and the alternate hypotheses are going to come from. The null hypothesis is that P, the proportion of gold beads after the activity, is 0.3. Alternate hypothesis, P, the proportion of gold beads after the activity, is less than 0.3. So these are our hypotheses. The reason the teacher told us that there was a large number of beads is so that we're not trying to find out how many beads were used, but just in general, the proportion and how the proportion may or may not have changed. Okay, so let's get on with the hypothesis test. Our alpha level, our significance level, is 5%. A quick diagram just to show all of the outcomes that may have happened when the teacher selected 20 beads out of the bag. Well, the minimum amount of beads that may have been gold is 0, and the maximum amount of beads that may have been gold is 20, and the expected amount of beads to be gold is 6. So all of these can go into the diagram. She actually got 2 beads from the sample. So putting that on the diagram as well, that helps us to decide the region we're looking for, the probability statement we need to calculate. The probability that X is less than or equal to 2. So BCD 02, 20, 0.3. That leads to an answer of 0.0355. Okay, so this is our test statistic, this is our p-value, this is what we're comparing to the critical region. This is smaller than that critical region value. We have a significant result. This means that we have evidence to reject H0. And in context, that means that there is evidence to support the teacher's claim that the proportion of gold beads is lower. The teacher specifically said that the students use more gold beads during the activity, which would lead to the proportion of gold beads being lower. So we just end off with both of those conclusions written out, both our mathematical conclusion and our contextual conclusion.